This is the Mark 45 torpedo, an anti-submarine weapon with a nuclear warhead. After firing, the torpedo dives or climbs to a depth of 100 feet for safety of the firing ship and for quieter running. At 2,050 yards, traveling at its designed speed of 40 knots, it dives to a preset depth. A depth monitor function prevents it from diving deeper than desired. Burst range and course can be changed by wire guidance during the run. An anti-circular run function prevents it from turning back on the firing ship. Maximum range is 12,000 yards. At the burst point, the warhead is detonated. This film gives an introduction to the systems of the torpedo Mark 45. The propulsion system of the torpedo consists of a 160 horsepower DC motor, a drive shaft assembly, 2 counter-rotating propellers, and a 250 volt, 550 amp water-activated battery. The heart of the course control unit is the gyro section, containing a course gyro and an anti-circular run or ACR gyro. Before firing, preset course is received from the fire control system. It establishes the initial gyro angle setting. After firing, the course gyro provides steering signals. The ACR gyro produces a signal to end the run if the torpedo turns more than 90 degrees from the desired initial set gyro course. The guidance receptor receives signals through the guidance wire from the fire control system. Course change signals are sent to the synchro stepper. The synchro stepper provides stepping pulses to the course control circuit in the control unit. From here, course error signals are fed to a servo amplifier. Rudder control signals from the servo amplifier go to the rudder actuator and to the rudders. The major component of the range control section is the integrator. This device, in effect, determines distance traveled by counting propeller revolutions. Before firing, the integrator receives burst range setting from the submarine fire control system. After firing, it receives burst range change signals through the guidance wire and guidance receptor. The integrator does not begin measuring distance immediately. Initially, this velocity switch is open. When the torpedo increases speed to about 27 knots, the force of the water rushing past causes the switch to close. The integrator is then able to start counting. The velocity switch is a safety device to prevent premature detonation of the warhead. At 400 yards, the integrator sends out a signal to activate the ACR circuit. This delay permits the torpedo to make a large angle turn while coming to initial course. At 2,050 yards, the integrator sends a signal to the depth control system to start the dive to final running depth and sends the enable signal to the warhead. 250 yards before burst, the integrator sends the arm signal to the warhead and disables the burst range change mechanism. At burst range, the integrator sends the burst signal to the warhead, initiating the nuclear explosion. The depth control system performs both normal depth control functions and a special depth monitor function. First, we'll see how the control functions maintain the torpedo at the proper depth. The depth control cell measures water pressure, which is proportional to depth, and converts this into an AC voltage. In the integrator, a depth command potentiometer converts scheduled depth to an AC voltage. The depth control and monitor amplifier compares these voltages and produces a depth error signal. The servo amplifier uses this error signal to produce elevator control signals, causing the torpedo to climb or dive to scheduled depth. A pitch pendulum provides stability to the torpedo and also acts to limit the climb or dive angle. When it is time for the torpedo to change depth, the integrator causes the scheduled depth voltage to change. This produces a new error signal, causing the torpedo to climb or dive until the new depth is reached. The depth control system's monitor function is a safety feature designed to protect the firing ship by preventing a deeper burst than desired. The depth monitor cell produces a separate voltage corresponding to actual depth. This is compared to scheduled depth by a special circuit in the depth control and monitor amplifier. If the torpedo goes more than 20% below scheduled depth, the normal error signal is interrupted and an up elevator signal is given. The arm and burst signals are prevented from being transmitted to the warhead until the torpedo has returned to a safe depth. The monitor circuit, while not one of the systems of the torpedo, is of special interest. It provides a go, no-go check of a number of torpedo functions during the warm-up period. It is a safety feature for the protection of the firing ship. The monitor circuit is powered externally with 26 volts from the warm-up circuit. The monitor circuit provides a check of the following: integrator range and depth units reset to 0. Velocity switch in 0 speed position. Synchro stepper in 0 or home position. The course and ACR gyros are checked to be sure they are caged. The warhead is checked for proper condition of switches, squibs, and connectors. The ready lamp on the fire control panel indicates whether these safety features are working properly. A blinking light indicates an unsafe warhead requiring jettisoning of the torpedo. No light indicates a torpedo or cable malfunction. A steady light appears only if every monitor circuit item checks out. After each exercise run, the torpedo is returned to a tender or a shore station for deck checking to ensure that all torpedo systems still function properly. Here we can see the sections and components of the exercise torpedo. The sections are tail cone, afterbody, exercise section, battery compartment, and exercise nose. The control package can be pulled out, exposing the pitch pendulum, the guidance receptor, control unit, course gyro, ACR gyro, servo amplifier, and depth control and monitor amplifier. After each run, the torpedo wire coil is replaced. The guidance wire test set provides a check of the guidance wire system. During the deck checking, a DC power supply test set supplies power, substituting for the torpedo battery. A warhead simulator substitutes for the warhead, providing a check that proper signals are sent to the warhead at the desired times. The tail cone drive stand turns the propeller shaft, providing the motive power for the rudder and elevator actuators. The presetter is a standard Mark 281 test set. The versatile afterbody stand permits simulating turning motions and climb or dive actions. By varying the pressure on the depth monitor cell with this dead weight tester, the depth at which the torpedo would be running can be determined, and depth control actions can be checked. The battery section is checked separately. This special test set determines whether the battery control devices are functioning properly. During a run, battery voltage is controlled by varying the rate of flow of seawater through the battery. When the checks are satisfactorily completed, the torpedo is ready to be returned to the sub. When fired, the torpedo immediately dives or climbs to 100 feet. At the same time, it comes to the preset course. As it reaches a speed of about 27 knots, the velocity switch closes and the integrator starts measuring distance. The ACR circuit activates, providing ACR protection. When at a safe distance from the firing ship, the torpedo dives to final running depth. The depth monitor circuit provides constant protection against explosion at too great a depth. With its built-in safety features and its powerful nuclear warhead, this weapon is as safe for the firing ship as it is deadly for the target.